This section introduces various casting methods. Casting is a process in which molten metal is poured into a mold with the desired shape and cooling it to solidify the metal. Even complicated shapes can be formed without other processes, and there is no waste of material. So, you may recognize the casting method as a forming process of higher efficiency. For example, manholes are made by casting. You may see other various examples of casting in our life. Comparing with making whole shape of casting products by only using machining, the advantageous efficiency of casting is obvious. But dimensional accuracy of the product is inferior to other processes. So, parts that require higher accuracy or lower surface roughness are finished by machining after casting. The main defects in castings include poor accuracy, defects on casting surface, shrinkage, cavity, and crack. Cavities are caused by gas generation due to chemical reactions or air bubbles due to excessive moisture in the mold. Shrinkage is caused by dents or dents that are insufficient to fill the mold. These defects can be caused by a variety of factors, including the die, mold, and the conditions under which the molten metal is poured. Casting method can be roughly categorized in sand casting, precision casting, and metal mold casting. Sand casting is the most typical casting method that uses sand molds. There are two more casting methods in precision casting: shell mold casting and roast wax casting. These casting provide higher dimensional accuracy and smoother surface. Another casting method that uses metal molds is called die casting. The dies used in die casting can be repetitively used, while dies used for the other casting methods are destroyed after each process. Contrary, in all casting methods, the model used to create the cavity are used repeatedly. Not all steel materials can be used for casting. Cast irons, such as gray cast iron and spheroidal graphite cast iron, are used. Cast irons have higher carbon content, and they are harder and more resistant to wearing than other ferrous metals. They can also absorb vibrations well. So, they are used for machine tool tables and frames. Cast irons can be molten at lower temperatures than ordinary carbon steel. This feature is more preferable for casting. Aluminum alloys are also used for casting by using sand molds and die casting. In the sand casting, a model of desired shape is made and then embedded in sand grains. After the sand is hardened, the model is removed to complete the mold. If the product needs a hollow-shaped core may be inserted into the mold. The molten metal is poured into the mold. The sand is broken to remove the product after cooling it down. Finally, the extra portion, such as riser, runner, and bar, are removed. The sand mold casting method is unique in that it can be used for a variety of larger and smaller shapes. The molds are broken after each casting process, but the sand is recycled. In the shell mold casting, the die is first machined into the desired shape. The mold is heated and blown with sand mixed with thermosetting resin to create a mold. The two molds are closed like a shell to create a cavity, and the molten metal is poured into the cavity. Products made by using the shell mold casting have smoother casting surface and higher dimensional accuracy. However, the heating process of the die is not suitable for casting of larger products. In the roast wax casting, a desired shape is made in a die. This die is used to make a model of wax with a lower melting point. When the model is rigidly formed with plaster and it is heated, the wax melts and the cavity of the desired shape is created. The molten metal is poured in here to form the shape. The model disappears each time. The mold is broken after the process, while the die used to make the model is used repeatedly. It is used for relatively small, intricate shapes and is often used for arts and crafts such as accessories. Productivity is increased by creating multiple cavities in a tree pattern for a single mold. Metal dies used in die casting method can be used repeatedly. Non-ferrous metals such as aluminum are molten and poured into molds by applying pressure die casting suitable for mass production of complex thin-walled shapes with higher dimensional accuracy. So, this process is widely used for automotive parts.